Good evening, everybody. My name is Shivam Pandey, and my roll number is 2010110766. And today I'll be solving Maths Homework 2. So here's the question which is I'm going to solve today. So we have provided with the trapezoidal region with vertex 1 comma 0, 2 comma 0, 0 comma 1, and 0 comma 2. We'll just assume we'll just name the vertices for this region. Let's say vertex A is 1 comma 0, B is 2 comma 0, C is 0 comma 1, and D is 0 comma 2. uh, for solving this problem, we'll just assume a new two new variables for this problem. Let's say v equals to y plus x and u equals to y minus x. By doing this, we'll be forming an alternative plane, and further that, let's solve the this equation. If we combine the above two equations, we'll be if we are adding the above two, let's say v plus u equals to 2y, which is y equals to v plus u by 2, and subtracting the above equation, we'll be getting v minus u equals to 2x, which is x equals to v minus u by 2. For the new plane, we'll be having a new graph for the new vertices, and the graph will be as follows. Here's the graph in which a is minus 1 comma 1, b is minus 2 comma 2, c is 1 comma 1, and d is 2 comma 2 vertex. As we can clearly see that the range for the v-axis is 1 to 2, and for the u-axis we'll be seeing the range for the AB line and the CD line. We can clearly see that the line AB, the equation is u equals to minus v, and the equation for CD line is u equals to v. So this implies that the range for u axis is minus v to v. Now, for finding the Jacobian of the above, for the new plane, for the UV plane, the formula is by del u del x by del v del y by del u and sorry del y by del v. As we can recall from the previous slide, we had equation x equals to v minus u by 2 and y equals to v plus u by 2. And from seeing this equation, we can clearly tell that del x by del u is equal to minus 1 by 2, and del x by del v equals to 1 by 2, and del y by del u equals to 1 by 2, and del y by del v equals to 1 by 2. So for the value of the Jacobian, we are getting minus 1 by 2, 1 by 2, 1 by 2, and 1 by 2. And now further solving, we'll get the value for the Jacobian will be 1 by 2. Now moving further on the question, let's get back to the how the question originally looked like. So here, since we have introduced a new variable, the equation will look like this. And for the new plane, we already know the ranges, which is v ranges from 1 to 2 and u ranges from minus v to v. So looks like 1 to 2 minus v to v cos u by v du dv. Also here we'll be adding the value of Jacobian into half. So now for the solving the equation, we'll be solving the integration inside out, which goes from here to here. And since the 1 by 2 is a constant, it will come outside the integration and it will look like half integration 1 by 2. And since we are integrating cos, it will become sine u by v, and we are integrating this with respect to du, it will become v and it ranges from minus v to v dv. Which will look like 1 by 2 integrating 1 to 2 sine 1 v minus sine minus 1 v dv. By 2 1 2 sine 1 plus sine 1 v dv. And from the trigonometric property, we know that the above equation will look like 2 sine 1 in 2 sine 1 into v dv. Now moving to the next step. So our last step look like half integral 1 by 2 2 sine 1 v dv, and we know that 2 sine 1 is a constant. It will come outside integration. The integration will look like 2 sine 1 v square by 2 ranging 1 to 2, and the 2 will cancel out and it will look like sine 1 4 by 2 minus 1 by 2, which equals to 3 by 2 sine 1. So it's the answer of the question given to us. Thank you.